And let me show you why the derivative of tan of x is equal to the secant squared of x. Let's see why that's true, because I did promise we will see it in one of the videos. The derivative of tan of x. So, that's the same as taking the derivative of sine of x divided by the cosine of x, right? That's pretty simple. Well, we can use the quotient rule now. So, the quotient rule says f over g. So f in our case is sine, g in our case is cosine. So we do f prime times g. So f prime is just the derivative of sine, which is cosine. So that's cosine of x times g, which is cosine of x. So that becomes cosine squared of x, minus f, which is just sine of x, times g prime, which is derivative of cosine, which is negative sine. So this is sine times negative sine of x, is in brackets, and then divided by g squared. So that's basically cosine squared of x. Well, you can see you have a negative and a negative, so that becomes a positive. So then you basically get cosine squared of x plus sine squared of x divided by cosine squared of x. Well, we know cosine squared of x plus sine squared of x is equal to 1. That's a very famous identity that you should know. And then 1 divided by cosine squared of x, well, we know that's the same as 1 divided by cosine of x all squared, because 1 squared is just still 1, and that is equal to the secant of x all squared. Secant of x is just 1 over cosine x, and this is equal to secant squared of x. So that means that the derivative, we started at the derivative of tan of x. That means the derivative of the tan of x, or the tangent of x if you want, is equal to secant squared of x.